Okay, well, we've seen what happens now when we have two bases to the same power and we multiply them together. What happens when we have the same base to two different powers and we multiply them together? So we have x a real number and the numbers m and n natural numbers. What happens when we multiply them together? That is, what happens when we take x to the m times x to the n? Well, x to the m, that means x times and so on times x, and this is m copies. X to the n, that's a bunch of copies of x multiplied together as well, but it's n copies. So put together, and dropping the parentheses because multiplication is associative, we have m plus n of the number x multiplied together. We have x to the m plus n. Now this is actually really cool because we've made some weird definitions that seemed kind of intuitive but maybe didn't make sense, that now we can make some sense of. So, if we know that x to the n means n copies of x multiplied together, and we want x to the m times x to the n to be x to the m plus n for m and n any integers, well, first question, what should x to the 0 be? Well, it must be that x to the 0 times x to the n equals x to the 0 plus n equals x to the n. So, what does that mean? X to the 0, multiplying by x to the 0 doesn't do anything. So x to the 0 must be the multiplicative identity. We must have x to the 0 equals 1. Well, for x non-zero, right? If x is 0, anything times 0 is 0. This isn't very interesting. But if x is not 0, x to the 0 must be 1. Even better. Okay, so all bets are off for x equals 0, but when x isn't 0, what should x to the negative n be? We want to have x to the negative n times x to the n equals x to the negative n plus n, which is x to the 0, which is 1. What? We want x to the negative n times x to the n to be 1. So x to the negative n must be the multiplicative inverse of x to the n. That x to the negative n equals 1 over x to the n, and x to the 0 equals 1, that seemed like such weird definitions. Those have to be true in order to make x to the m times x to the n continue to equal x to the m plus n for all integers m and n instead of just the natural numbers. Alright, let's just see an example of this. We know that 8 equals 2 to the third and 16 equals 2 to the fourth. So 8 times 16 should be 2 to the third times 2 to the fourth, should be 2 to the 3 plus 4, should be 2 to the seventh. On the one hand, 8 times 16 is 128. On the other hand, 2 to the seventh, also 128. So at least for those three numbers, we see that this really does work out as expected.